Let's take a look at some piecewise functions. Okay, first of all, a piecewise function is a function composed of several different pieces of graphs. Several different pieces of graphs. So you're going to have several different equations, several different pieces of graphs, all coming together to make one function. Okay, first of all, everyone needs to write big F of x equals, and then you draw one of these open braces. Okay, that's the hardest part about this section. So taking a look at this graph, how many pieces does this one have? Good, the answer is 3. So there's going to be a piece, and a piece, and a piece. And then comma, comma, comma. Then you have to say this piece is good here, and this piece is good here, and this piece is used here for those x values. So what I highly recommend doing is coming over to the graph and maybe writing the equation of the line. So this is a linear equation, so it's going to be y equals, it's going downhill. Take a look at the slope. Down 2 over 1. Negative 2x. Now I need a b value. And I think the easiest thing to do for the b value is to just keep going. Down 2 over 1, down 2 over 1, down 2 over 1. This line would touch right there. If the whole line was drawn, it would touch right there at negative 1, 2, 3, 4, 5. So the b value is negative 5. You could also calculate the b value by doing some linear equation work. Y equals mx plus b. Okay, take a look at this piece right here. This piece is horizontal. That's a hoy. That's a hoy. This line, if the whole thing was drawn, would be y equals negative 3. 1, 2, 3. That's a hoy. And how about this? This is also a line, uphill line. So this is going to be y equals. Can you calculate the slope, please? Good. Up 1 over 2. 1/2. Y equals mx. Now I need a b. And let's just keep going. Down 1 over 2. Down 1 over 2. Down 1 over 2. The b value, if I keep going, would be plus 0. Now you don't need to write 0, but I'm doing that just to make sure everyone knows you have to find the b value. Okay, now back over here. We have f of x. We already have our y. I'm going to put the first piece right here, and it's y equals, so we don't need to write another y or another equal sign. I'll just put the rest of his equation on this first line. Negative 2x minus 5. Now I have to say, where is this line drawn? It's not drawn the whole line. It's just drawn from this x value all the way to this x value. So if you take a look at the graph paper, that piece is only from here to there. So let's go small to big. Negative 1, 2, 3, 4, 5. From negative 5, since that's a closed bubble, less than or equal to x, all the way up to negative 2. That's another closed bubble. So less than or equal to negative 2. Okay, remember, closed bubble is going to be greater than or equal, less than or equal. An open bubble will just be greater or less. But when you're doing the sandwiches, we always use the less than signs. Okay, now let's take a look at the second piece. The second equation is y equals negative 3. We already have the y. We already have the equal sign. So the only thing we need to put here is negative 3. Okay, and now what are the values? Because I don't see an entire line, it goes from negative 2 all the way to positive 2. From negative 2, x is in the middle, all the way to positive 2. Now you have to put less than signs. In negative 2, it's open, so we'll just put the less than. Positive 2 is filled in, so less than or equal. All right, and then this third piece over here, y and equals are already there. The only thing we have to put in the line is 1/2 x. Now I notice that this line starts at 2 and goes forever. So I'm going to say x's that are greater than 2. So when you look at a piecewise graph, don't forget to say y equals your big bracy, the 3 separate equations, and then the values where they are. And this work right here, this is like domain. It's x values of where the graph is drawn. Okay, let's take a look at this one right here. Let's get ready with our f of x. F of x equals big bracy. And how many pieces does this one have? It's got a line, a parabola, and a line. So it's got 1, 2, 3 pieces. Comma, comma, comma. You always have to say where the piece is valid. Okay, because it's not the entire graph, it's just a piece of it. All right, I really like going over to the graph, and I like writing down the information on the picture, and then I'll transfer it over. So let's just focus on this one right here. This is a straight line. That's an uphill line. So that's going to be y equals mx plus b. What's the m? 1, 2, 3. Up 3 over 1. 3x. 3x. Now I need a b value. Now some people like to go up 3 over 1. Up 3 over 1. Up 3 over 1. I think it's going to touch way up there at plus 10. Now let me show you another way, because sometimes it's way off the graph paper, and other times it's a fraction. And you can't just guess when it's sitting in the middle of a box. So what we're going to do is we're going to look at this line right here, and I know that the slope is 3. And let's find a point that you see on this graph. I think I'm going to do negative 3, 1. That looks pretty easy. Nice and small, negative 3, 1. So what I'll do is y equals mx plus b, and I'm going to calculate the b by doing algebra. Okay, especially if the b value was like negative 72. So give me a y, 1. Give me an m, 3. Give me an x, negative 3. Plus b. You will have to know how to do this technique because not all the problems are this nice. Negative 9 right here. And if I add 9, then we get a 10. Okay, the b value is definitely a 10. All right, let's take a look at this middle equation here. The shape is a parabola. So I know it's going to be y equals. I don't see any shifting. It wasn't shifted left or right or up or down. Was it reflected? Not necessarily. Is there any stretching? Over 1 up 1, over 1 up 3. Oh, this looks like the regular growth pattern. This looks like good old x squared. No shifting, no reflecting. Just a basic parabola. And the last piece, this looks like a horizontal. This looks like a hoy. So the equation for this guy is going to be y equals, let's see, 1, 2, 3, 4, 5. Y equals 5. All right, a lot of the hard work was done over here. Now we just have to put all the pieces together. So the first piece is this line. The y and the equals are already there, so I'm going to start with 3x plus 10. Now where is this line drawn? I see that it goes down, down, down forever this way. So it goes from negative infinity all the way up until x value negative 2. And since that's a closed point right there, you could put a bracket. I think I'll put a bracket. Now here's a question. What if this line had the open bubble? And what if the parabola had a closed? If you have an open bubble, and then you have a closed bubble, and they meet, do you see what happens to them? They join. So here's an open bubble, and what if it joins up with a closed bubble? Do you see what it looks like? It looks like it's filled in, but it's hard to tell if the open bubble was from the first one or the second one, or maybe they were both closed bubbles. As long as someone gets a bracket, we fill that value in. Okay, what if, here, let me show you another picture. What if we have an open bubble? Hook up, and what if it meets up with another segment right here that has an open bubble? Do you see what open plus open makes? Open. Okay, and if somebody's closed, it's definitely going to be filled in. Let's take a look at the next one here. The parabola. Y equals, all we need is x squared. And this parabola goes from -2 all the way up to +2. I'm going to put brackets on -2, +2. And the last one right here, y equals, all I need to put is the 5. It starts at 2 with an open bubble, so I'll do parentheses from 2 all the way until infinity. Okay, now some people at home might be wondering, why is she changing it up? Okay, and here's a couple of things. The notation that I did up here, this is called inequality notation. If it says use inequality notation, then you use the greater than less than signs. But these answers down here, I wrote those in interval notation. So if it says use interval notation, make sure you use the brackets and parentheses. If it doesn't say, use whatever you like. But a lot of times with piecewise, it'll be given to you in either one way or the other. Okay, so the first half of the lesson was, can you write equations when you see piecewise graphs? Now for the fun part. Now we're going to actually graph piecewise equations. Okay, we're going to graph them. So everybody needs to get out their pencil and that really cool eraser that I gave you. And we're going to graph the following. 1, 2, 3 pieces. Okay, I'm going to put a little note up here. So I always want you to plug in the endpoints. Okay, it kind of helps to have the endpoints in mind. So for this first piece, I'm going to take -3 and plug it in. -3, negative is a +3 plus 1 is 4. So we have -3, 4. And now I want to plug in 1. -1 plus 1 is 0. So 1, 0. Okay, this is going to be helpful later on when we're drawing our graphs. If I plug in 1 right here, there's really no place to plug it in. So when the x is 1, the y is just 8. Okay, and the last one, let's plug in 1. 1 squared is 1, -1 plus 5 makes a 4. Okay, so we're taking the values and we're plugging them in. Those are going to come in handy in just a moment. Okay, I'm going to zoom in here for the graphing part, and then for the question part, I'll zoom back out. Okay, for our first piece, we have a straight line. So we've got a downhill line. The b value is 1, so let's start at 1. Now make sure you use a pencil for this. The slope is downhill, -1, down 1, over 1, down 1, over 1, up 1, over 1, up 1, over 1. Okay. Now I recommend using a pencil and perhaps drawing very lightly. Okay. So here's the line. There's the downhill line. Except I don't want the entire line, do I? I only want the line if x's are between -3 and 1. So if I go to -3, -1, 2, 3, I'm at this point right here. -3, 4. Oh, good. That matches. Now, do I want to equal -3? And the answer is yes. So right there, I'm going to put a closed bubble. And I'm going to use the piece of line that keeps going, 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 all the way to 1. At 1, the point is right there, at 1, 0, except this says less than. So that's going to be an open bubble right there. So I want the piece of graph between x values, -3 and 1. That's the only piece I want. So notice how I highlighted that with my marker. Okay. Then, the rest of the line, goodbye. I don't want this piece. Get rid of that. And erase this piece. Okay. So the technique here is draw the whole graph and erase everything so you only have the piece that they wanted. Okay. Piece number 2, y equals 8. That's a y equals 8 is a horizontal line up here at negative 8. Here is the horizontal line. Okay, make sure you use your pencil. Except I only want it if x equals 1. X equals 1? Well, if x equals 1, that's right here. I don't want less than 1. I don't want more than 1. I only want 1 point. Oh, that's really weird. Okay, so take your pen or your marker, and we're going to fill that in. I want that point. And what about the rest of this line? Goodbye, line. Goodbye, all of that, and goodbye, all of that. Okay? The more experience you get, the more you'll not draw such of a long line because you're going to notice, I only want 1 dot, so let's just get the rest of that. And the third piece. Okay? The shape of this piece is parabola. It's shifted, reflected over the x-axis, so it's going to be opening down. And it's shifted 5 units up. So let's make sure we get out our pencil. We're going to go up 1, 2, 3, 4, 5. And how does a parabola go? Over 1, down 1. Over 1, down 3. Over 1, down 5. I don't think I can fit 7. Okay, so just draw a very nice, light parabola. Okay, there's the parabola. Except, I don't want the entire parabola. Okay, I only want the parabola if x is more than 1. So let's find 1. Let's go to that point on the parabola. Is the point 1, 4? Yep, that's where it is. Good. And do I want to draw an open bubble or a closed bubble? It says greater than 1. Some people say, well, why don't we go to 2? Well, the answer is you have to put open bubble on 1 because what about all the graph that's between 1 and 2? So you start at 1 with an open bubble, and you want the graph that's greater, greater, greater. I'm going to highlight these points so my teacher can grade it. And what about the rest of the parabola? Goodbye, rest of the parabola. And here is your first piecewise equation. And what you could do with something like this is take some stickies or some pieces of paper, and you could test. There's no grass that way. And then purple, purple, purple. So the first piece that I see is this purple piece between -3 and 1. -3 and 1. Then I see a green piece right there. How many dots do you see? Just 1. These are empty, so those are not points. There's only 1 point there. Then, if I go past 1, greater than 1, I only see the red graph. You should never have 2 pieces in the same section. Only 1 piece at a time. Okay? Is this a function? Does it pass the vertical line test? Definitely 1 section there. There's only 1. How about that point? Does a vertical line only touch once? Yes. Okay. In fact, that's one of the questions over here. Is f of x a function? And the answer is yes. Okay, let's answer some more questions. Find f of 0. A couple of ways you could do this. You could plug it into the equation, or you could look at the graph. If 0 is the x, the y value is 1. The y value is 1. You could also plug it in and do algebra like you did the day before. Find f of 1. Plug 1 in. Outcome is the value 8. Let's plug in 2. X value of 2, and we get 1. Find the domain. Remember, the domain's a set of x values. The smallest x value, let's see, the smallest x value is right there, -3. -3, that's a closed point, so we'll put brackets from -3. And then the graph keeps going, 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 all the way until infinity. Okay, let's find the range. Smallest y value. Smallest y value is -infinity with parentheses. Okay, let's keep going, going, going. Does the graph use 0? Absolutely, as long as it uses it somewhere. Keep going, going. Does the graph use that value right there? Is 4 being used? Yes, it's being used. But then 5, 6, 7's not. So hang on. We got to stop right here at 4. 4 with some brackets. So is that it? Does the graph only go to 4 and stop? Well, no. Hang on. There's some more graph up here. So you have to say union. And it starts at the value 8. So brackets 8, comma. Now you have to put a stopping number. Does it stop at 9? 10? No. It stops at 8. Starts at 8, stops at 8. So how do you say a point? You say the same number 2 times. Start at 8, stop at 8. That's kind of different. Question O right here. Is F continuous? Let's see. Is it continuous? Let me show you what continuous looks like. Okay, so continuous would be something like this. There's a parabola that stops. Then it hooks up with a horizontal line. And then it hooks up with an uphill linear equation. Do you see how the three pieces all hooked up and touched and are connected? Is this graph connected? No, it's not continuous on its domain. That means from here to here where the graph is it all connected up? This one here is continuous, but that one is not. Okay, and the last one right here, let's go get that pencil out again. The first thing I'm going to do is plug in the values. Okay, so the first thing is I'm going to plug in 2 into this equation. So 2 minus 1 is 1. 1 squared is 1 times 2 minus 5 is negative 3. Okay, my second piece, let's plug in, I have to plug in 2 to 6, the endpoints. So let's plug in 2. 3 divided by 2 times by 2 is 3. 3 minus 6 is negative 3. And then we also have to plug in 6. 3 times 6, 18 divided by 2 is 9, and 9 minus 6 is 3. And the last piece, let's plug in 6. 6 plus 3 is 9. Square root of 9 is 3. A negative 3 plus 9 is 6. Okay, so we're plugging the number, we're plugging the value into the x right there to see our end points, and that helps us with the graph. Okay. Equation number 1. This is a parabola. 1 unit to the right, 5 units down. It's opening up, and that 2 right there means vertical stretch by 2. Okay, let's go 1 to the right. 1 to the right, 5 down. Okay, and let's not forget to stretch by 2. So over 1, up 2. Over 1, up 6. Over 1, up. Oh, it's not going to fit. Okay, so here's the parabola. Here's the parabola, nice, tall, stretchy one. Okay, except this parabola needs to be, let's see, less than 2. So let's go to 2, x value 2, and I'm down here. Oh yeah, 2, negative 3. Good, it's working. And I want to be less than 2. So should I equal this point? This is going to be an open bubble. And then I'm going to go less. So all of this parabola right here is going to be nice and highlighted. Less, 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 less. All these points nice and dark. And what about all the parabola to the right? Oh, I'm so sorry, parabola, but you got to get erased. No parabola more than 2. I only want parabola less than 2. Let's make sure these points here look nice and dark. Okay, so the parabola is less than 2. All right, next one. Oh, this is just a line, an uphill line. Let's get my pencil out. Okay, I don't want to do anything in pen because I have to erase half of what I draw. Down 6. 1, 2, 3, 4, 5, 6. The slope is 3 halves. Up 3 over 2. Oh, right there. Up 3 over 2. Up 3 over 2. Up 3 over 2. Okay, so I'm going to draw a nice line right here. Nice line. And now let's get out our marker and see where we want this line. I want the line if x's are between 2 and 6. That's going to be an open bubble, and then that's going to be an open bubble. So let's see. Let's go to 2, and I'm right there. Right there. Hey, what happens if an open meets an open? I'll draw an open. An open on top of an open. Is it filled in? Certainly not. And that's working. -2, -3 is that point. 3, 4, 5, 6. I'm at 3. Yep, 6, 3 is the end point. And that one's also going to be open. And so I want the line between 2 and 6. And so what you have to do now is a very good job of erasing all the line that's less than 2 or more than 6. Okay? And now I have to make sure that I tell you guys something. Okay? Right there, make sure you erase really good. Okay? And I don't want no bullseyes. Okay? Do not do anything like this on a test. I get very confused if that's supposed to be open and you didn't do a good job of erasing, or if it's supposed to be filled in and you didn't color it well enough. Open bubbles or closed points. That's all we got. Okay, our last one was a square root. Okay, and that negative, well, let's do pencil. This negative right here wants us to reflect over the x-axis. Now, a regular square root would go up, 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 up like this in quadrant 1. Reflecting over the x-axis, it's going to be going down, down, left. I'm sorry, right, down, down, right. Except I have to go 3 to the left and 9 up. 3 to the left, 9 up. Here's the square. It's going to start right here and reflect it. So down 1 over 1, down 1 over 3, down 1 over 5, down 1 over 7 off the graph paper. So here's the square root, oops, going down, down, right, down, down, right, down, down, right, except I only want the piece that's greater than 6. So if I go to 6, it's that point right there. But I'm going to be greater than 6. Greater. So open or closed bubble there. That's going to be an open bubble. And then I want all the graph greater to the right. So let's go ahead and erase all of the square root that's to the left. Only keep the square root that's greater. And let's do a check. Let's take our hands or some pieces of paper to see. You should only have one color of graph at a time. One color of graph at a time. One color of graph. Find f of 0. 0 gives us 1, 2, -3. Let's find f of 1. Plug 1 in. 1, 2, 3, 4, -5. Let's plug 2 in. Uh-oh. 2 is an empty bubble. Do you remember what to say for this? No solution. No solution. There is no graph there. That's an open bubble. Make sure you draw nice-looking open bubbles. The domain goes from -infinity all the way until there's no graph at 2. So 2 parentheses union. Let's start up again at 2. And the graph keeps going. Oh man, there's no graph here either at 6. 6 parentheses union 6. And then it goes forever to infinity. How about the range? What's the smallest y value? Oh wait, that's not the smallest. What's happening down here? Isn't the square root going down, down, right, down, down, right, down, down, right? It's getting there slowly, but it's going to keep going down, down, down. So the smallest y value there is -infinity. That's really weird, but that's what happens with the square root. And then if you come all the way up, there's graph being used. There's graph being used here. There's graph being used all the way up to infinity. Is f continuous on its domain? And the answer here is going to be no again. Okay? Can you graph a piecewise function with an eraser? With an eraser and endpoints. Okay, that's the technique that we're going to use. Make sure you bring those erasers to class tomorrow. I can't wait to see you graphing and then erasing. Can you write a piecewise equation? And can you use the graphs to find information? I sure hope so.